5.6 cargo carol.
Okay,
First squirrel.
then we will cruise through this, see where we stand, hopefully we'll be good. All right, good morning, everybody, happy Monday.
Happy Monday.
There's no what?
This has just been.
All right, yesterday we read this problem. We talked about what was coming, so we figured today let's do it, right? So here we go. We're talking about Hurricane Katrina. I have great confidence that you can read this, that you don't need my help.
Actually,
Considering I read it yesterday, that should be enough. So we have to figure out how to do this. Okay? Knowing what we're working on, you can probably have some type of general idea where we're going to go. So what do you think is step one?
Find our limitations.
Even before the inequalities. Even before that.
Writing down all the numbers.
Before that. Define variables. Got to define the variables. Especially in these problems, defining the variables gets very important. Okay? Here I left up their definition of the variables, their defining of the variables. I left that there. So we have x as the number of cases of water. We have y is the number of generators. We're going to graph this stuff at some point, right?
Yes.
How are we going to deal with the z? Why did they have z here?
Because it's your
But are we going to have a three-dimensional graph?
No.
No.
Yeah, I know, me too.
It's a realistic so
Right, so what is the z for? What will that be involved in? The objective function, that's exactly right. So let's put the z over here for now, because we'll deal with, as we talked about yesterday, we'll deal with the objective function last. And z is the number of households aided.
I did that one. If it's at an awkward skew, that's my bad.
We'll worry about that in a little bit. But our graphs, as we know, our graphs are going to be two-dimensional. We're going to have the x and the y, right? So, for the time being, let's talk about this stuff. Okay, what's next? Our constraints. Okay. Do you see any info in there that might be where we're going to get the first inequality?
Each truck must contain at least 10 tons.
Okay, so help me out. Give me the first inequality.
No more.
6,000.
X is?
X plus y.
X plus y.
I think x is less than or equal to 6,000. Oh wait, it's not bad.
So what will the first inequality have to do with? The weight.
Yeah.
The weight. Okay? Tell me about the weight.
More than 6,000 pounds.
25 pounds for each case of water. 150 pounds for each generator. So give me the first. So let's try that one again. Give us the first constraint.
25x plus 150y is less than equal to 6,000.
Make sure that before you start writing things down there, that you know what it is that you're working with. You have a plan. Okay? The first constraint here, as soon as we start talking about 6,000 pounds of cargo, we can't be saying x plus y because x and y have nothing to do with pounds. They have to do with numbers. So if we're going to talk about pounds, then we got to find other stuff in here that deals with pounds. Does that make sense? So each case of bottled water is 25 pounds. So the 6,000 pounds is going to have to do with the 25 pounds and 150 pounds. And that's why that's that. Okay there? Is that all for the constraints? Okay. So we have another constraint. Where is that other constraint going to come from?
Very less, so.
How many of each helps a house?
Say what?
How many of each, like, thing helps a house?
Okay, but isn't that Z? The households aided is Z.
No, like the number of those that aids one household.
Right, and all of that, because that's what we're trying to maximize, all right? So that's going to be part of that. Somebody was mentioning where it would come from.
Oh,
The
last.
the last sentence. The last sentence. Now, you got to be careful here, because there are a couple of issues in this. So try to write that last constraint. So, talk it out, figure it out.
Okay, so 10 x. 10x. Y is equal to 6. That is y is equal to Oh, so y is equal to
Because if you did the number of generators times 10,
10x is greater than or equal to 5.
but you need
That makes sense.
Do we have anything?
10 times
Y
is
is less than or equal to 10x.
Well, we know it's gonna be 10x because it's.
Y is less than or equal to 10x.
Oh, wait. No, that's not it.
Wait, no, that's the,
I don't know, we're trying to figure out. I just wrote down what somebody said.
because if it's at least.
That's what I thought.
It's probably flipping the sign.
You think we should move the 10 to the other side?
Yeah.
Why?
Would you?
Why is it not?
At least, so just flip the sign.
I didn't hear what you guys said.
Flip the sign.
Okay, so he's agreeing. So can somebody tell me why? What are there more of?
Water.
More water. So if we take the number of cases of water and multiply it by 10, will that give us the number of generators?
No.
No. But if we take the number of generators and multiply it by 10, will that give us the amount of water?
Yes.
Yes. So the 10 has to go over there. Okay there? This is why we talk. Are we happy about the sign?
Yeah.
I'm just asking.
Because y always has to be less than x. If we have more
Yeah.
cases of water than generators, right?
Y always has to be less than X.
I mean, we're always going to have less generators than we are going to have cases of water.
Right, but we're not talking about how many generators. We're talking about 10 times the number of generators, right?
Yeah.
Well, that's what I'm trying to figure out. I'm not saying that, okay, so if we're not sure, what can we do to decide whether we're going to be right or whether we have to flip it? Plug something in. Okay? All right, give me an example of something that should work.
One generator and 10.
I don't want to go 10, that's, you know, it says at least, right? That's our concern. Our concern isn't 1 and 10, our concern is 1 and 15. Right? With me at all? We're trying to decide whether it should
Oh,
be
yeah,
less than
yeah,
or
yeah.
equal to or greater than or equal to.
Okay, yeah, yeah.
So if we
I'm
plug
with
in
you.
1 and 10,
I'm with you.
well, that's gonna be the equal to, so that doesn't help us decide which direction this flies. So plug in something that should work. If we have 1 generator and 10 cases of water, if we have 1 generator and 15 cases of water, is that okay? Yes. Okay, so 1 generator, 15 cases of water is okay. Does 1 generator and 15 cases of water work with what we have right here? Yes, it does. 1 generator, 15 cases of water. 10 is less than or equal to 15. That's good, therefore the sign is right. A simple inequality, but there were 2 significant issues there, right? So just be careful. Talk your way through it. Reason your way through it. You can do all this stuff. You're all very bright. You can figure this out. But don't just assume, okay, it says 10 times as many cases of water, so 10 times the number of water. Got it, 10x. No, that doesn't make sense if you really think about it. With me there? Is that all the constraints that are in that paragraph? I think so too. But there will be 2 constraints that are there pretty much all the time on these types of word problems. Talk to me. X is greater than or equal to 0. Y is greater than or equal to 0. Because it makes no sense to be negative. We're going to take -3 generators.
My
Does that
favorite
mean we
amount.
Go to Louisiana and steal 3 generators? Is that what's happening? Well, that certainly will help people, won't it?
Yes.
So you know what I mean there. It doesn't, these typically are going to be constraints in most word problems. Okay, is this all of our constraints? Yes, it is. So what should we do next? Not yet. I'd love to do the objective function first. If I do the objective function, then I can blank that out and we can graph right over the middle there. That's my thought. So, objective function. Where does that come from? Here's how I can tell it's the objective function. Determine the maximum. What's our goal in these types of problems? Find the max or find the min, exactly, one of the 2. So somewhere in the problem is going to be something that tells us maximum, minimum, greatest amount, least amount, highest, lowest, whatever. Okay? That tells us right there, this is your objective function. So, how do we do it? Z equals. Did you say y plus 5x? Okay. I agree. Let me ask you this. If you have 20 cases of water, how many households are you helping? 4, right? But according to our objective function, the way it's written right now, if we have 5 cases, or if we have 20 cases of water, how many households are we helping? If we have 20 cases of water, according to this, how many households are we helping?
5.
So, 100, right? 5 times 20. So what don't you like? I don't like, you don't like the way the 5 is? So what do? Change it, okay. Why don't I change it to 2? Does that work? Of course not. So give me something besides change it. Not 1/5. How do you feel about 1/5? You're good with that? In this case, if we have 20 cases of water, how many households will we help? 4. Yeah, that's what we want, right? Does that make sense? So in all of these, even though a lot of times the numbers look very straightforward, they're not always quite as straightforward. So take a minute, plug in stuff, make sure it works the way it's supposed to. Questions there? Now what should we do?
Graph.
Now we should graph. So, time to graph. So let's set up the graph.
It's
Oh, not the graph I wanted at all. I'm not thinking. What do these two constraints really do to our graph?
Oh, maybe.
put it in one.
So we only need quadrant.
They limit it all to quadrant 1, don't they?
Uh-huh.
So
Ow.
if I set up the graph, why
Sorry,
don't I
pencil.
just basically do quadrant 1? Is that more reasonable?
Yeah.
All right, so let's see what we got.
No, I think you should put the extra 4 quadrants wasted of space.
Got- I realize that the scales of the graph are not the same on the x and y axes, but it doesn't really matter. Doesn't matter how it looks, it just needs to be functional for us at this point. So, where should we start?
The top first constraint.
This guy?
Yes.
Okay, talk to me.
Let's move.
Uh,
Oh, no, we can do 0.
6,725.
Yeah, I would find, for me, I would certainly find intercepts.
Yeah.
So what's the first one you're trying to find?
X.
The x-intercept, which means we would make y 0.
240.
Y is 0, x is
240.
240. If y is 0, x is 240, so that puts us right about in there. Okay?
And then find a y.
Y-intercept, so we're making
X0.
x 0, if x is 0,
40.
Y.
40.
40.
Yep. 15 goes into 60 4 times, so 40. Are those all the points we need?
Yeah.
Yep. Thank you, dots. Ready? Here we go.
Woo.
Ooh,
Good
that's a
one.
I like that one. Now what?
Shade underneath.
Shade. Underneath? Why?
Yeah.
Because it's less.
0, 0.
Well, I mean, I've done number. I mean, because I've like when graphing and we did a lot of things, like know which ones, like patterns.
The 0, 0 makes it true.
0 plus 0 is less than 6,000, so shade 0, 0.
That's true.
Okay. So underneath is correct. Remember, don't go crazy. Just make sure we know which side is being shaded. Now you'll notice, because of these last two constraints, we're staying in the first quadrant, so I didn't shade anything outside of quadrant 1. Is that okay? All right. Nice. Next, second one. Talk to me.
X is 0. Never mind.
Not saying you're wrong, I'm just, we have x's and y's here, right?
Uh-huh.
Can we move them both? I mean, we could divide by 10, but that's not Or you put the x there, so now it's not y,
So talk to me. Y-intercept is 0? You guys agree with that? Y-intercept is 0?
Yeah.
Yeah. If y is 0, x is 0, right? Anytime you have an equation that has no constants in it, this one had 6,000. This one has no constants in it. If it has no constants, then a point that's on the graph will always be 0, 0. Yep. So there's nothing to add or subtract or anything like that. You're just saying, in this case, 10 times 0 equals 0. Okay? Could be 3 times 0 equals 2 times 0 or something like that. All right, but that gives us 1 point. And unfortunately, that's both intercepts. So we need another point. What is?
Well, no, let's make y
10 comma what?
1.
10 comma 1, I agree. But instead of making, why don't we, I mean, is it easier to plug in a number for x or for y right here?
X. Y.
To me, you missed by 1. It's much easier to plug in a y, isn't it?
I would.
Because then we're just multiplying by 10 to give us the other one. So
What do you mean 10?
let's make y
10.
10. Why 10?
Because that would make x.
It's on the graph. That's why I would make it 10. Okay? If y is 10,
X is 100.
x is 100. How do we feel about that point?
Good.
I like it.
Y is 10, x is 100. So, okay, y is 10, x is 100. There we go. We do another point?
We don't really need to.
I know, but I didn't ask if we really need
yes.
to. I said, can we?
Yes, we can.
What would be another point that you might come up with?
20, 100.
200 comma 20. Y is 20, x is 200. That wasn't that bad, was it?
No.
And no, we didn't have to do that, but maybe it makes it a little easier to graph, to draw the line, a little more accurate, something like that. He likes to criticize. Now what? Shading. We don't know which side we're shading yet.
Let's try to do it. No, we can't.
Some of them.
Let's try it. 0.
100 comma 0?
That'll work.
Well, you could,
Yes. Yeah.
Yeah.
As long as we pick something that's not on the line. I tend to pick things on the x-axis. I don't know why. It doesn't matter. You can pick anything as long as it's not on the line. So if we go 100 comma 0, x is 100, y is 0, true or false?
True.
True. X is 100, y is 0.
True.
0 is less than 100. True. So therefore, we're going to shade 100 comma 0, which in our quest of just graphing the stuff that needs to be graphed, what are we talking about?
Just red triangle.
The triangle.
Little triangle down in here. So tell me about that triangle.
That is our feasible
It's our
region.
feasible region. Yes, sir.
Isn't the x-axis vertical line?
The line, no, well, I'm just talking about shading the blue, shading on the blue line.
Oh.
And so the x-axis is not part of the blue line, so it's okay to use. That's our feasible region. Every point in there works for all 4 of these, right? Okay. Tell me about our feasible region. What does it look like? It's a triangle.
There's 3
How many vertices are there in the feasible region? 3. That looks like one of them? That looks like one of them? That looks like one of them. Do you agree? Cool. We have to get the coordinates of those points, correct? Some of them are easy, right? 0, 0. I agree. Wow, you guys figured that out? Is that?
Well, no, because we did it before we found the x-intercept.
Oh, that was the x-intercept for that line, so it makes sense that you would know it beforehand. Good. 240 comma 0. And that one. And that third one. And so the question becomes, how accurate is our graph, and where is that? And
What lines intersect?
I don't know for sure. So they are 2 lines that are intersecting. Which 2 lines?
Blue and the
Blue and the
The
black.
blue and the black, which therefore are
top.
these 2. So what do we have here?
System.
System of equations. We're looking to find where the 2 lines cross. Basically, we're solving the system of equations. That system is 25x plus 150y equals 6,000. And 10x, nope, 10y, that's what I said, 10y equals x. We have a system of equations. What is the easiest way to solve that system of equations?
Plug in 10y.
Substitution.
Substitution, absolutely. Because we already know
Comes with the same answer,
what
but
x
a
is.
different
We know what
answer.
x is. X is 10y. So let's go to the x and put in 10y, so 25 times 10y plus 150y equals 6,000. 250y plus 150y equals 6,000. So 400y equals 6,000. Cancel 2 of the zeros. 4 goes into 60 15 times. And y is 15. If y is 15, then x is 150. Which therefore makes this point 150, comma 15. And we now have the vertices of our feasible region. So, all we have left is go to the objective function. Yep. So we have them. Now, what are we trying to do with the objective function? We're trying to find the maximum. I feel very confident that I know which one it's not.
0, 0.
I feel very confident, okay, that if Jake loads onto his truck no water and no generators, that will not be the best for the people of Louisiana. I feel very confident about that. Now, what will 0, 0 do to that function?
Make it 0.
It will,
Make it equal 0. It is
it all starts with
0.
an M.
Minimize?
It'll minimize it, right? Because remember that the vertices of the feasible region will give us the maximum value and the minimum value. Just so happens that here, obviously, 0, 0 would give us the minimum value. It would give us a z of
0.
0. Okay there?
Yeah.
What's next?
I mean, but 240. Oh, wait, I'll just. I mean, because if we have 240, 0, it doesn't make sense to have 0.
240, comma 0.
Can't have 0.
240, comma 0. Gives us what?
48. It doesn't make sense.
Z is 48. And then comes the point that we all expect will be the point, right? 150, comma 15. And if we plug in 150, comma 15, we get a Z of 45. So according to the problem that we have right here, what is best for the people of Louisiana? Water. Lots of water.
240 cases of water and 0 generators.
Yep. 240 cases of water and 0 generators. Which, given the statistics that we have, is the right way to do it.
Is that careless whisper?
Yeah.
Sexygrams.
Now, we can all logically argue it if we want, but in terms of the information that we've been given on this problem, this is what we have. Now, what is our answer to the problem? Well, that very much depends on what was the question. So,
48 houses.
it's hard to answer the question, or it's hard to give an answer if we don't know the question. That's what I'm trying to say. So, determine the maximum number of Louisiana households aided by each truck. 48.
It doesn't make sense.
48. Okay?
We're in a.
Well, hang on. Let me get back to that in a second. According to the info that we are given, the maximum number of households that can be aided is 48. It also says here, and how many generators and cases of water should be sent in each truck. So in each truck, there should be
240 cases.
240 cases of water,
0 generators.
0 generators. Okay? All right. Do we understand what we did? All right. Now we can argue. Let's get it going. Long term, clearly this doesn't make a lot of sense, right? So maybe this is for days 1 and 2. You know, people are in trouble. What do they do? What do they need? They need water. I don't know. I'm just, you know, trying to argue. But here's the other thing. Your role, your job at this moment is not underling, but somebody who's not the decision maker. You are the statistician. You are the person that crunches numbers to come up with the best case scenario. Okay?
You gotta help the most amount of houses.
That's when you're 25. When you get to be 35 or 40, you get to make the decisions. And so what do you tell them? Well, you say, all right, 5 cases of water will not aid a household. It's going to take 8 numbers. It's going to take 8. It's going to take 8 cases of water. So now, how do we change that? Now that becomes 1/8, and now that 240, 0 becomes, when we plug in 240, 0, we get 30. Now we only get 30. We plug in 150, 15. 150 would give us just a little bit less than 20. It would give us like 19, 15, which would give us 34. And now, this 150, 15 becomes our better answer. So what we're doing is we're setting up, we're making decisions based on the numbers that we are given. And we can't do anything besides that. Okay? We need, if the numbers change, if we disagree with the numbers, then we got to go out and we got to say to the powers that be, I'm sure about these numbers. Because it's hard to imagine that we shouldn't bring in any generators. Yes, sir?
Also, like, if all of their houses are flooded, how would they use the generators?
What do you mean?
So, like, if they're sending generators over, but everything's flooded, like, wouldn't it?
Well, the generator might help pump, might help a water pump that can pump out the water. I don't know. Depends on the situation. And of course, you know, we're talking about, we're following the problem in an Algebra 2 book. And we're not there on the ground in New Orleans in 2008. 5. I'm sorry, 2005. We're not there in 2005 going through and dealing with all of that. So we don't know. But maybe, you know, maybe the first couple of trucks, the first day or two of trucks